We are still in DOS. Where we have left our TSR program unfinished. Yeah, this is not even Windows 3. I have a small mistake here. This +1 is not really needed to calculate the number of paragraphs. This already rounds up. You know, one of these off by 1 errors. So far, we have demonstrated that in DOS you could simply write to interrupt table and intercept hook some interrupt vectors and mess with the system, like change the way the clock works. However, as I also said last time, TSRs were not really a malware or anything like that. This was just a regular method to do something in DOS, to provide some additional services, some additional drivers. But then such TSR should be able to keep things clean. So prevent itself from installing more than once and be able to uninstall itself. And for this we need a method to detect whether the TSR was already installed and not install it twice. So let's think about possible schemes for detection. We could just look at the interrupt table and look at vectors that this TSR hooks and try to recognize that one of the vectors is hooked by this program. We could even add some additional signature. So this uninstall interrupt handler. We could try to recognize the instructions, but they are very generic, so any handler could start in a similar manner. Well, maybe not any, because this does not preserve the registers, but still, we would not be really sure that this is our program. We can also try to add some signature. Just to demonstrate, I'm going to keep it short, but the longer the signature, obviously, the more sure we can be that we recognize our own program correctly. let's use bx because we want to address memory. ES register is free for use. And we are looking for this signature at negative offset, because the signature is before the handler. So we need to subtract 2 and look for this signature. Yeah, a function call. We are going to get to this in a moment. Because each method has different advantages. Well, in this case, let's display some message. And we also need to exit program. We are going to be using forC function because it allows to add return code in AL, that is in lower part of AX. Well, and here it was exit code 0, stay resident. Okay, the second time it detected itself. We have a sped up clock, but at least TSR is now a single copy in memory. You can also see I have quickly installed another TSR that I need to run fast. This is a DPMI driver. So what is the potential flaw of this method? When there are interrupts or interrupts functions that can be chained, for example, one program installs its handler of an interrupt to provide some functions, and another one installs its own handler on top of that, because, of course, as we already know, any program in DOS can overwrite everything. But it can still jump to previous handler. For example, it can recognize that the function that program expected when called the interrupt was not the function that this TSR provides, so it may then jump to handler of previous TSR, and this would be a nice thing to do. So when a TSR wants to play nice, it allows to chain with other TSR drivers together. And then we would no longer see the signature this way, because while our function could still be called because of chaining, it would no longer be visible as interrupt vector, because the vector currently in table would be set up by another program. So this method is not completely reliable. When there are other programs that may interrupt the same interrupts that we do. So another approach is to play nice, chain itself together with other TSRs and just use some specific function to detect itself. So let's now try this other method. Instead of having our own interrupt, we are going to use one of the interrupts that are already known to provide some functions, and we are just going to add our own function to them. Let's use a keyboard interrupt, for example. This is 1.6. This is no longer appropriate. Now, this is a, let's say, public interrupt. Many programs are using it. It has many distinct functions, so we need to play along, preserve all registers when we want to do something. Oh, and another thing. We are going to detect our function. Perhaps our function can be called by having this signature in AX register. For detection, and let's say another function for uninstalling. I do not modify any register. I do modify flags to make conditional jumps, but in interrupt we do not really need to preserve flags, because iRet restores flags from the stack. I could show it perhaps like there is call and ret. Call pushes address on the stack, and ret then pops the address and returns to that address. Then when you want to use iRet, setting up stack is two instructions. You would have push flags and then push address to return to, and iRet pops address to return to and flags. We may need this later, I don't know. But for now, this explains why I do not preserve flags. And here I can just jump to previous handler. But I need to store. I am now storing two different vectors. use this convention. So this one is for IRQ. And this one for the other interrupt. So here we jump to previous handler when we do not detect any of our functions. Now function detect. Oh, okay. In our own function we no longer need to preserve registers. This is for our program only. Let's say that let's simply swap registers. This then becomes reverse string. And function uninstall, we know already what to do. We are restoring this handler and the other one. And we also need to free up the memory. Let's look it up. Oh, okay, this is the function. Function number 49. ES should be segment to free. In case of program, segment that the memory block allocated for program starts on is the segment of PSP, program segment prefix. In case of COM programs like this is just the same segment as CS. Alright, we have the functions. Now we need to use the function to detect. When we get this in response, then we know that program is already resident. Oh, it did not work. Yeah, a small mistake. I have installed it on vector 8. What saved me is that I am jumping to previous vector anyway. This is why the clock still works. Yeah, detection now works correctly. And we can see that it hooked interrupts 8 and 16. What remains is the ability to uninstall program. And for this we need to handle command line. Let's take a look at documentation once again. In the program segment prefix, at offset 80 there is command line. It ends with caret return character. And first byte is length, but we can skip length and just keep looking until we see the caret return character at the end. So let's start looking at this address. The S segment at this point is still equal to CS segment because this is the entry point of COM program. When this is a space, we keep looking, and let's say that small letter R is enough to go to an installation. Yes, the only reference I keep using is Ralph Brown's interrupt list. Uninstall. In case of uninstall option, we also need to detect if it is installed already. This is going to be another error case. And when we see that it is installed, then we use the function and it should now uninstall itself. For now, let's restart the machine because we have many copies in memory already. Okay, installed first time. The clock is sped up. We are not able to load it more than once into memory. And let's try uninstalling. Has been uninstalled. The clock is running normal. And there is no longer TSR in memory. Success. Great, so we have a complete TSR program that hooks two interrupts. And what it does is it speeds up the clock 5 times. I think this should be enough for this episode. Thank you for watching.